The Pennsylvania State University, College of Earth and Mineral Sciences, Department of Energy and Mineral Engineering presents Impedance Spectroscopy, Electronic and Ionic Impedance, Laboratory Instructional Video. Equipment and Materials. We will need an LCR digibridge for impedance magnitude and phase angle measurements, a custom-made circuit board with 3 RC circuits labeled A, B, and C, the conductivity cell for measuring aqueous ionic conductivity, distilled water, and 0.01 molar sodium chloride, and a 100 milliliter test beaker. Experimental procedure. Add approximately 50 milliliters of the sodium chloride solution to the test beaker. Position the conductivity cell above the beaker and lower it to ensure that the plates are completely wetted by the test solution. You may want to swirl the water around to ensure no bubbles remain attached to the platinum plate. Next, we'll connect the impedance bridge to the conductivity cell. Attach the red clip to the white wire, the black clip to the black wire. We'll then ground it by attaching the green clip to the uninsulated gray wire. The red and green wires from the conductivity cell are for temperature measurements and won't be used. Next, we'll power up the impedance bridge with a button on the bottom left and give it a minute to run its boot up sequence. Press the F2 button and set it to 0.25 volts. This is the amplitude of the applied potential. We'll then press F3 until ZS is shown on the left, that is impedance magnitude. Press the right arrow and then continue pressing F3 until theta appears on the screen for phase angle. We'll now use the F1 button to cycle through frequencies. First, set the unit to 100 Hz. Wait approximately 30 seconds for a stable reading in impedance magnitude and phase angle. Next, we'll press the F1 button to set the unit to 120 Hz. Wait, take the measurement, and repeat for 1 kHz and 10 kHz. We can now power off the impedance bridge, disconnect the conductivity cell, rinse, dry, and store the conductivity cell. Please return the sodium chloride solution to the storage container so that it may be reused. Impedance spectroscopy in RC electric circuits. We'll now set up the circuit board using the ring stand and clamp. Connect the positive and negative leads from the impedance bridge to circuit A. We'll then power up the impedance bridge and set it up using the same protocol as before. Record the impedance magnitude for 100, 120, 1000, and 10,000 Hz. And finally, we'll repeat this same process for circuit B and circuit C on the same circuit board. When the final measurements have been taken, we may power off the impedance bridge and return all materials to where they were acquired from.